Hey everyone, welcome to Two Car Pros. My name is Ryan and today I'm showing you exactly how a relay works. I got a comment asking how a relay works recently and I thought that was a very interesting video idea, so here it is. I've also already done how to wire a relay and that video is located in the description for your convenience. With all out of the way, let's jump into it.
So before we talk relays, let's just look at a normal automotive switch system. So we have a light bar here. These are very popular in the aftermarket. They're on a ton of vehicles that people wire in themselves. And it might be why you're looking up this video. So this is pretty basic. Negative connects to the device. We have our switch in between the device and the positive. You can also put the switch on the negative side. That's usually the better way of doing it, but this is just for instructional purposes. You can see I flick the switch, it completes the circuit, the light bar turns on, and you might be thinking, well, that's great. Mission accomplished, right? Yes and no. So for this little teeny tiny light bar, this switch is probably sufficient, but this switch is only rated to handle 5 amps, maybe. This isn't even close to 5 amps, I'm sure, because it's all LED, but what if you need to power something bigger like an electric fan or a lot of these lights? Well, that's why you're going to need a relay. So let me wire one in. Okay, so now our setup looks a little more convoluted, but I promise it is very simple to understand. So we'll start at our battery. This would be what would be in our car, and then we have it come out and give a ground to our light. But where's the power coming from? Our power is going to come from our relay, and that gets its power from the white wire here. There it is, all the way back down. So the relay's got power and a ground. Awesome, it has a bunch of power going to it, and this relay right on the top says it handles, I don't know if you can see that, 30 amps, which is a bunch of power. Almost nothing in an automotive application besides maybe like a big water pump or an enormous set of fans uses more than 30 amps. This is more than likely going to cover you. Alternatively, you can use bigger relays or even really big size contactors if you're working on something industrial. So now that this has power and ground, it has the ability to give that. It needs to know when to send that. And it uses an electromagnet to do that. I'll show that in just a bit. But how does it know when to send the power to the light? It's all hooked up and it should light. But it doesn't because we have our switch wired in. And what the switch does is feed a teeny tiny amount of voltage to the relay, completing the circuit on the electromagnet side of it. So it energizes and holds two big contacts together that feed power over to the light. You'll be able to hear those contacts click. So now, instead of just hearing the switch, you can actually grab it and feel it. In my right hand, I can feel it go little click. So there you go. That is connected. And if you want to know exactly how to wire this in and why you should do it that way, I have a whole video teaching you exactly how to wire a relay, but I just want to show you how one works. So let's pop this open and you can see a first-hand look on how a relay actually functions. Okay, so this is how a relay works. Actually, I've removed the cover. Don't do this at home. You could have the potential to shock yourself. Let me do it. So when we complete our circuit, i.e. turn our switch on, look what happens. Those contacts touch and the circuit is complete. The big power circuit is complete. That's basically what's right here. And you might look at that and go, oh wow, that doesn't really seem like that robust. I promise you in the world of electronics, that is actually a pretty big deal. And the bigger deal is how it joins together using this electromagnet. So the electromagnet isn't charged right now because I'm not completing the circuit. So there's no repelling magnetic forces here or attracting magnetic forces. But when I complete the circuit, power is fed to this electromagnet and it brings those contacts together. When I release, the spring tension of this side of the contact point is separated with just spring, just a spring. That's what does that. That little bend right there in that copper or brass essentially acts as a spring. And when energy is fed to this electromagnet, these coil windings, it draws down that piece of metal, that contact, to the other contact, completing our circuit. And look how fast it joins and separates. Why is that important? Because of arcing. Arcing is essentially when us humans take too long to turn something on or off, like a light switch. That's why light switches click. They basically have a built-in way of minimizing arcing. So because of that spring, those contacts separate really quickly, and that's important due to arcing. Arcing is when contacts take too long to separate and electricity is still flowing between the 2 points, and that can ruin those two surfaces. It can create resistance, and resistance equals heat equals fire, never good. So a relay is a really good way to ensure that a large amount of power will be able to flow and minimize arcing for years and years to come. These do fail, but not as often as you might think. They're actually pretty robust and reliable. So yeah, that is how a relay actually works. Pretty cool.
So that's how a relay works in an automotive system. That's how it works for fuel pumps, fans, some electric water pumps, anything that requires a large amount of power. Anything that pumps usually has a relay attached to it. Because think about it, that teeny tiny signal can come from a computer. So now you have a computer sending out a very small amount of voltage to control something big and powerful like a fan or a fuel pump, which is exactly how all modern cars work. So what I showed earlier is exactly what is in your car right now. Might be your problem, might be worth looking into, replacing. Those relays do go out, and they're really cheap and easy to replace. Kind of interesting, a little bit fun, kind of a shorter video, but I hope you enjoyed it all the same. If this video has been interesting or helpful at all, please consider becoming a member by clicking that join button down below. It's a direct way to help the channel out. Barring that, a like, comment, and subscription go a long way, and I so appreciate that. Thanks again for watching, and I'll see you next time.